Hello everyone and welcome back to a new video in modeling, analysis and design of reinforced concrete structure. Now previously we have basically finished, or not finished, we have basically went through a big chunk of modeling the right side tower. Now while I'm looking, I think I messed something up. Very simple, yeah. I think this wall is not existent in the generalistic and the general story, so I just quickly delete those things. Well, but that's not the topic of today's video. In today's video, we're going to continue our modeling efforts and we are going to try model the left side structure. So with that being said, sit back, relax, and enjoy the show. Alright, so to start with, I have an amazing suggestion by our dear subscriber, Engineer Sarpei. He's saying that you could have done the circular slab much faster if you have imported the DXF background into the structure with the slab bounds. And you know what? He's 100% right. So I would like to thank them, first of all, for this amazing constructive comment, and we are going to do this today. So, okay, let's start with our AutoCAD. Now, this is the drawing that has the columns, and I will go to the general column, to the general drawing here, and copy the bounds of the slab. So I'll just copy those things. I'll also select me one of my columns. Okay, now Control C, not copy, Control C, because I'm going to do a copy clip, because I'm taking it to another drawing. I'll Control V now, and I'll paste this, and then I'll move it via the move command using the column I copied here. Why is this copied? I use the column here to move my slab bounds into position. Okay, so now our slab bound is into position. Now, I don't know if Robot will see this arced polyline or not. I don't want to go through any chances. So what I will be doing is, first of all, I will draw me a helper line. So I'm drawing basically the center of each arc. Those are two arcs because architectural drawings, and he draws the thickness of the wall. For us structural people, we don't care about the thickness of the architectural wall, not the shear wall, of course. And yeah, I will just draw me a center line to help myself align the drawing in Robot. Because if I remember correctly, and I might be wrong, we will see this today, I think that Robot does not see or show arced polylines. Also, I need to deal with this in center-to-center fashion. So I think we are ready now because I can't connect to the column. I think we are ready now. Yeah. So I will save this as again, and we'll save it as a DXF file. I'll call it columns 2 because why not? And I think it's saved. So let's go to Robot and try import this. So I'll go to File, Import DXF Background, and import column 2. Of course, it's asking me where to put it. I think I would keep it the same because I think this was my center. I think I have done this in the previous videos. Of course, if you're wondering, if you're a first-time visitor to this channel, this is part of a YouTube series about Robot and a series typical about reinforced concrete buildings. Both series I will be linking on the top right. The position on the Z-axis, I have no idea where the position should be. I think I will put it here. So let me just click here in the Z-axis. There we go. I'll hit OK, and fingers crossed. And I think we're good. See, some of the arcs are missing. There is no arc here. Although in the drawing there is an arc, here there is no arc. So this line is actually helping us, if you see it. This little line here is helping us. So do I have the center lines everywhere? Just click on top. I cannot see anything. Actually, the color is really bad. Can I change the color of the background? I don't know. Yeah, there we go, color. Let me change the color to something that I can easily detect and see. But I still see that there are some lines missing. So for example here, this line is existing. This line here is missing. This line here is missing. Oh, this line here is missing because there is no arc here. There is this here, this door. And this arc here missing because there should be an arc, right? In the top floors, there is an arc. No arcs? Okay, no arcs. Fine. Okay, so it seems we are not missing anything. Okay, so let's do this. Let's try our best with that. I go to floors now. And what was the thickness here? 200 still? I might need to change the thickness later. So I'll select shell here, thickness 200, go to contour. Is it sensible to do it in one swoop? I don't think so. I think I should do it in multiple pieces. I'm thinking, what is the best way of implementing this to help the mesher mesh? You know what? Let's start with the easy part. I'll just do this one. 1, 2. Ah, I misclicked. Escape. There we go. 3. And here. 4. And here. 5. And here. 6. Okay, I have my first piece. It doesn't look... I missed a point. Yeah, it doesn't look well. Okay, Control Z and repeat. Computer is really slowing down now. I don't know why. Let me just try again. I'll just click correctly and the center point here, and the edge point here, the edge point here, the center point that I have forgot, and the edge point here. Okay, now this looks better. Yeah, I think this looks better. Is it not symmetric? Wait, is my structure unsymmetric? Yeah, it's unsymmetric. You see, this bulges more than that. That is spicy, to say the least. Yeah, see, this bulges more than this. This is 4.08. It's not symmetric. Okay, so far so good. Let's continue with our shell. You see that I am trying to get my first line to align with the global X for reasons I've explained before. You can check out the Slab series to understand all the intricacies of modeling slabs and shells and whatnot in Autodesk Robot. I'm still doing this, so I think maybe the editor will speed up. I don't know, to be honest. Okay, so once again, this strange thing where this slab is not carried by anything. I think I've talked about this in the previous video. I will deal with the staircase later because I need to think about the staircase. Also, once again, a shout out to our dear channel subscriber, Engineer Sarpei, who actually talked about the intricacies of making a staircase. He's actually saying that, in a nutshell, you can read his comment, it's very beneficial, that it's not really recommended to have a beam stick out of the wall because of cold joints and so on. I totally agree. I am 100% with this issue. Okay, so I need the first line to be an X, right? Strictly speaking. So I'll just click here. One click. And now it's an X. I need to be careful where I click. I mean, you have seen me struggle with a basement wall in previous videos. This is all a slab, right? Let me just check. Yeah, that's all a slab. There are no empty spaces, right? So here. Okay. I need just to be a little bit careful here. I can just click one click here to fill it because there is no arc here. It's fully filled. And here and here. Okay. And now I need to somehow click extend. Can I click extend? It doesn't. I wish I could click extend, but I cannot. There's no extension. I'll cancel this because I need to capture this point. Unfortunately, I have to go to my AutoCAD again and basically to my columns here and basically add me something that captures this. So I'll just click on L here for a line from the center point here to the center point here. There we go. Yep, and now I will save again. And now Robot should tell me that something has changed. So let's go to Robot. Yes. And there we go. Okay, now I can draw. Of course, I'm leaving a staircase for later. I need to think about it. But let me tell you right now, I am inclined to adding one column here, and that's it. But I will give this a future video. Now here I have a slab, so I click on this. Okay, now here I had some issues in the past, right? I was thinking how to do this. Should I extend the slab? I think I should extend the slab. So here, I think I should write an L here, draw a line from the center here to the center here. Wait, what? Okay, please snap well. So I'm snapping here and I'm snapping here, and now both extensions should intersect here. Perfect. Okay, this is the extension of my slab. This slab is going to be carried by the left side. Okay, so I think this is the cleanest way of doing it. All right. Which means I need a center point here. I'll do it. So I'll go here and add me a center point. I don't have one. Oh, that's annoying. Save, and now it updates in Robot, of course. It doesn't update. Oh, there we go. It updates in Robot. And I have a line. Fantastic. So I go to contour now. I'll intentionally draw this. Wait, I draw this in X first. So I need to click the first line like this because I want the local axis to be parallel to the global axis in X. It makes my life easier when dealing with the results. I know some of you are robot pros and they know that they can switch the results to be in the global axis sense no matter what the local axis is, and you're right. However, that's how I roll, so I think I'm doing it correctly. Finally, this one, I need to click here 2, column here 3, this edge point 4, and this one is 5. Fantastic. Of course, this only exists in this story. Okay, so it seems we are doing fine so far. Okay, now let's do some some beams. So I'll just go click here, select me a beam. There is gonna be a lot of commentary in the future. I am unhappy about what I'm doing here. This is a large span and I'm using a small beam with 300 by 500. This is unacceptable, to be honest. I'll add me a section to be by 700 just to be a placeholder because I might change this in the future. Okay, now there is something I want to talk about very quickly. This is something that the beginner engineer falls into. I know you have codes, and I know that the easiest way to deal with those things is to go to your code. For example, the ACI code says that if you have a span simply supported, although it's going to be a frame, but if you have a span simply supported, then the height of the beam is L/16. And you just calculate this and assume your thickness to be in line with the recommendation of the ACI code, and that's it. Now, this works fine usually. The practical issue is that you have a height of a story. The height of the story is 3.5. If you add yourself a beam, and let's say that the beam is like, I don't know, 300, so 0.3 in this direction, and 0.7 in this direction. So this is your beam now, the white one. Okay, I know it's a little bit awkward. You see, when you define a beam with a certain height, you are taking away of the clear spacing of the story. Like the story had a spacing of 3.5, now it has a clear spacing of 2.8 because you took 70 or 700 millimeters away by using your beam. Not only this, there is another issue. You see, you sometimes might, if you live in hot areas, you might have central air conditioning flowing through the building. So you have all kinds of mechanical fittings moving here in this region. And those mechanical fittings, if it's a central AC, might need to cross below your beam, further decreasing the available clear height for you. And finally, you might need to cover this by a false ceiling or a gypsum board or something, and the false ceiling itself needs some thickness or some height. So now I will not be doing this in this series so far because I don't see a reason to do that so far. I'm assuming that there is nothing like that here. But I want to keep this in mind. I want to just remind you that, hey, there is a height that you need to keep in mind here, and that is the height of the person. And you cannot just put the slab 20 centimeters above the person's head. This will cause all kinds of problems, and the architectural engineer will actually scream in agony when he sees that. So keep that in mind when you assume thicknesses. For me now, I will do a beam, a placeholder beam, 300 by 700. Of course, I need to deal with this in the future. So I'll just click from here to here. That's my first beam. And you see where this is going. Now this beam must extend cantilever itself. This is going to be a cantilever beam all the way until the edge of the slab, which kind of makes sense. Now I'm thinking about this here. Like, how will I beam this? Now, of course, I need a main beam here. This is a no-brainer, so I'll just click here, one beam. This is a main beam now. There we go. Okay. That's a no-brainer for me. Now, how would I carry this? There is a column here, a shear wall here, not aligned, and a beam here. I could beam it from here to here. I think I should. I think I should beam it. Let me just give a beam here. Okay, this kind of makes sense to me. I need a cross beam. Oh, this beam is gonna be heavily reinforced because this beam will carry a lot of load. Okay, I'll just go to my secondary beam. I'll ask it to be 500, which is gonna be this. This is gonna be a carrying beam, so it's gonna be 500. So let's click here. There we go. And let's continue the beam from here all the way to here. So it's gonna be carried by the other beam. This here, this is one of the danger zones. You need, do I have to carry it like this? I'm not really convinced if I need a main beam here, because a slab is available to carry itself, and it's going to be carried by those two beams. Like this beam is going to extend to the wall, of course. Like this is going to extend to here. Wait, why did it break like this? Wait, what? Oh, okay, no, this is not dangerous. Because the wall has a thickness, so of course the beam is going to be carried by the wall. I'm kind of annoyed. Should I add a beam here? I think I will. I think I will, and in the future, if I see that it was not needed, I can basically just remove it. Okay, so there is a beam here. I'm using the 500 now because this is a carrying beam, I think. Now I'll go to the 400 because I will just do the surrounding beams. So I'll drag them and basically start clicking. Okay, so the ground floor seems to be completed. I still have some reservations with regard to this region and the staircase, but that is something I will have to do later. I need to add this to my to-do list, which I have right here. So I need here to add and say 10. I think it was south, west beams. Okay, so it seems we are doing good so far. The only thing that remains here is to copy this multiple times. And it seems that this is happening once, twice only, 2 times? Is that the case? I think that's the case. Does the height change? No, it's 3.5s, right? Yeah. Of course, this here is an architectural thing. Let me see. This is level 1, level 2, level 3, and level 4. Let's take a look on the plan views. Level 1. Okay. Level 2, that's correct. Level 3, that's correct. And there is no level 4. Okay, so level 4 is purely architectural. This one is just an architectural thing, which I might model in the future. Wait, does it need to be modeled? 1 slab, 2 slab, 3 slab. Yeah, I think I should model this. I think this is like 3.5 to 0. Okay, I think I see where this is going. This is going to be spicy. But for now, I'll copy it 2 times. So I'll go here, and let's do it. Let's go there. Let me just select this stuff here, and just go to Edit, Move or Copy, and copy it 2 times with a height of 3.5. So 0, 0, 3.5. I'll execute this. I think the supports get copied too. Do they get copied? I think yes, right? Only the supports of the walls get copied, so I need to delete this. And for some reason, my columns seem to arc when I copy. This is kind of strange. I don't know why this happens, but this is the second time I capture and catch my columns changing their gamma angles. That is peculiar. So I just select all my columns, and I go to my gamma angle. I'm really surprised why this keeps changing. So just put it to 0 back. Okay, there we go. And now I need to remove those because there is no, this here is the bridge, this is the top of the bridge, and here there is no bridge, so I can delete this. This needs to be deleted. This needs to be deleted. There we go. Also, I think I misclicked and I copied the columns of the bridge. Now, this is not a really bad move, but I think I should be a little bit more careful. So I select like this. I have the node. I have 1 node. Do I have 1 node? Yes. I delete and ask it to delete the member. There we go. Okay. Similarly here, I select very carefully. I have one node. I delete the adjacent, and now I think we're doing good. I should not have copied this, because this might be for the next time, because I think I don't want to make my video too long. I'll keep the bridge for the next time. There we go. Okay, so now so far so good. What remains is the cool factor, because it seems that the entire thing is sloped. Based on what I see here, that the entire thing is sloped. How can I do that? But the columns continue. How is that possible now? The columns seem to continue up, but the thing is sloped. I don't think the columns seem to continue up, because they do? Really? Is that the case? Or is it just a case of an error? I'm not really sure, to be honest. I don't know. I don't see any architectural prowess in doing that. Okay, how can I do this here? How can I do this? I'll copy this first of all 3.5 meters up. So I'll just go to the front like this, take this and say, oh wait, there is the support. I forgot about the support. Let me go to the support here. Linear support, delete the linear support for all the walls. So no linear support here. Yeah, I think, okay, now we deleted the supports. I can go to front, select this, and say edit, move, or copy. Okay, now I need to somehow trim stuff. What is this node? There is a node here. What are those nodes? Those are the remainders of the deleting of the columns. Okay, let me delete those. I'm still thinking how I can do this. Now, first of all, those are not here. So this is not here because this doesn't extend. Does it extend? Let me just check. No, those doesn't extend. That is a little extension, but that's not, this is not consequential for the structure. So I can, and this is where Revit is good. You could model this easily in Revit and import it in Robot, but Revit is not part of my tutorial today. So I deleted those things, and now I need to do some cool factor here. I need to break this via a plane. You see, it seems that it is starting at 1 meters here and ending here. Or let me say from the center point. Edit, cut by plane. Again, 3 points, so center point of this column. There we go. Center point of, or edge point of that column. Edge point of that column. Cut off. The side here is this one. There we go. And objects, those. Apply. Hey, look. I think it worked. Did it work? I think we did it. Okay, I think we did it. Let me just check. Yeah, I think we've done it. This is the remainder. I'll just delete those survivors. I think it worked. Yes, it did. This is next level modeling in Robot. To be honest, I'm proud. Wait, where is the column here? And where is the column here? They got deleted? Why? They should not be deleted. I'll just copy them. I will just copy them. No deal. I won't let a technicality destroy my happipiness. I will now go to this because it's symmetric, so it should be copied. I'll go to this, go to edit, move or copy, and copy me one copy from here. Let me just try to click it correctly. From its base to this base. There we go. We copied it successfully. And now I'll go again to, I'll select this and go to edit, move or copy, and copy it yet again from its base to, okay, where was the missing column here? I think this was the missing column. There we go. I'm utilizing the symmetry of the structure. Okay, and now I think I'm warranted, after all this effort, I think I'm warranted here a break, and I think I can simplify it. By simplifying, I mean simplifying this circular thing. If I understood correctly, I'm not sure, because, let me just check. Where is the section? Here is the section. There we go. Okay, this is a false ceiling, it seems. Yeah, there is a false ceiling here. So there is no concrete here. Here, there is no concrete. This here is empty. It's false ceiling. You can see those things. Okay, so, but why? I mean, you could leave it open, right? But that's not me, that's the architect. So now I will have to delete what I have done painfully. Maybe I should not have deleted the beams. Yeah, the beams, the outside beams should not be deleted because you need them for the glass works. When you have glass, something needs to carry the glass, right? There's aluminum profiles, and those aluminum profiles need to rest or be fixed into a concrete element. And I think those beams would be the perfect concrete elements. So I'm Control-Zing and deleting those things. You see, I'm trying to show you this from a... Let me just copy those things because I don't want to mess anything up. I'm trying to explain everything in a practical sense. So I'm sorry if I sound strange because I don't want to delete the external beams. Let me just move them. So I'll copy them from here to here because I'm thinking of the glass. I'm thinking of the external scaffolding. Sorry, not scaffolding. I'm thinking of the external, what's it called? Facades or something. I forgot what the name is. Okay, so I will simplify things here, okay? So let me explain to you what I mean by simplifying things. I will copy delete those beams. There we go. And now I'm simplifying by making one beam, not like this broken beam, but something simpler, because I think I'm warranted to do that. So I'll select reinforced concrete beam, not horizontal, drag, and start drawing me a nice and dandy circular beam without the central point, because I think you have all the tools necessary to do it yourself. For me now, I just do it in a simplified manner. There we go. Now, if my understanding is correct, I have cut it using a plane. So this should be planar. If I go to shell and select horizontal, no, select contour, what I will draw right now, accept those two cutting points, should be a plane. It should not have a problem with it. This is something that will be checked in the future, but at least I'm now thinking loud because I cut it by a plane. So everything that was cut by that plane should be a perfect planar element. So this should not have a problem when we run our final element analysis all the way until here, because that was one of the points for the cutting plane. And this one here, I need to see correctly. Where is it? There we go. And let's finalize. Okay. Of course, here the final one, this was the cutting edge. Now I need to have my X correctly. So I'm intentionally drawing my first line in the X, as you can see. Similarly here, I'm drawing my first line in the X to have my X aligned with the global X. Okay. Wait, what? I need to close the triangle. Yes. Okay. Fine. Finally, I have to do my beams. Once again, I think I'm warranted a simplification here because of all the effort I have done. So yeah, that's everything I wanted to talk about today. I think we're done. I think we have yet again finished a good chunk of the modeling of the structure. And before I finish, I want to give a huge inclined slab-sized shout out to our dear channel members in the contributor level and the helper level, whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as the support of the channel is priceless to me and enables me to basically keep pushing those videos with a certain level of quality that I try to achieve. Of course, with that being said, I hope that you enjoyed the video and that it was beneficial for you. Of course, if you have enjoyed the video, then please consider providing a sacrifice to the YouTube algorithm overlords by hitting that like button, subscribe button, share button, and especially subscribing because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye-bye.